Hi everyone and welcome back to Maths and Physics, Mr. Simons. Today is grade 12 trigonometry lesson number 3 of 9. We're looking at identities, but now we're going to reduce compound angles to prove identity. Most of the time we're going to end up with special angles, right? So, given to us to prove that sine 70 cos 10 cos 70 sine 10 equal square root 3 over 2, alright? So I know the sine of 60 is square root 3 over 2 or the cos of 30. Right? Now, if we look at the left-hand side, they gave me sine 70, cos 10, cos 70, and sine 10. Now, the key I'm looking at, they have 70 degree for sine, and I have 70 degree for cos on either side of the negative sign. Then I have 10 degrees and 10 degrees. Sine cos, cos sine means I'm going to use the compound angular for sine. So we should know when we expand sine A minus B, it becomes sine A cos B minus cos A sine B. So look there, sine A, sine 70, cos B, cos 10, cos A, cos 70. So you see there, they're the same. And sine B, same as cos 10. So I can reduce it, and it becomes now sine 70 minus 10 degrees according to the formula. 70 minus 10 gives me 60, and the sine of 60 equals square root 3 over 2, which equals my right-hand side. So the key with this problem, and the problems we're going to do, is whether we can reduce from expanded compound angle and make it a single trig ratio, right? Instead of having sine cos, we're either going to make it sine or cos. So I hope you follow this. Let's look at problem number 2. In problem number 2, I have cos cos, sine sine, right? The key is the angles. So my first trig ratio here is 69. There my first trig ratio on the other side of the plus sign is 69. First trig ratio here is our second trig ratio 24, second trig ratio 24. They want 1 over square root 2, so that means either we're going to have sine 45 or cos 45 degrees. Right, so my left hand side, cos cos, sine sine. So according to compound angle formula, cos cos, sine sine can be reduced to cos A minus B. So I go from more than one trig ratio, cos and sine, to a single trig ratio, cos. So there, if we reduce, that becomes cos 69 plus, always change the sign when it's cos cos. So that becomes negative. So 69 minus 24, which then gives me cos 45, which equals 1 over square root 2. So this first two is relatively simple, but we can also change these angles in such a way that we test your reduction skills that you learned in grade 11. So let's look at a more complex problem. So now number 3, they gave me cos 291, cos 24, plus sine 111, cos 66, equal 1 over square root 2. So again, I'm done reducing this. I'm going to end up either with sine 45 or cos 45. Because sine 45 and cos 45 is 1 over square root 2. Alright, there they gave me cos cos, but I don't have sine sine, so I'm going to have to change. So number 1, I have to make this angle and that angle the same side. This angle and this angle the same side, but if this is going to stay cos, then that must become sine, because then it becomes cos cos, sine sine. If I'm going to use cos cos, sine sine, I'm going to use this compound angle. It says cos A minus B equal cos A cos B cos cos plus sine A sine B. Right? So 291 falls in the fourth quadrant. It falls between 270 and 360. So if I reduce, that becomes 360 minus 69 degrees. Right, I'm not changing cos 24. So now the key is, can I make 111? 69, 111 degrees falls in the second quadrant between 90 and 180. So I can say 180 minus 69. So they have introduced 69, 69 on both sides. To change cos to sine, remember I want sine. I'm going to use 90 degrees on my co-ratios. So from there, 90 minus 24 gives me 66. So now I have 24 degrees and 24 degrees. 360 minus falls in the fourth quadrant. In the fourth quadrant, cos is positive. So therefore, it stays positive and it becomes cos 69, cos 24. 180 minus 69 falls in the second quadrant. The second quadrant sign is positive, that simply stays sine 69. Cos 90 degrees minus 24 falls in first quadrant. The first quadrant, everything is positive. So that simply becomes then sine 24. The 90 changes cos to sine. So whenever I bring in 90, cos changes to sine, or sine changes to cos. So now I have 69, 24, 69, 24. I have cos, cos, sine, sine. So if I reduce using that, that gives me cos 69 minus 24, which then becomes cos 45. And cos 45, special angle, 1 over square root 2. If you try to use your calculator, it's going to give you square root 2 over 2, but the real value without the calculator is 1 over square root 2. Remember, your calculator rationalizes the denominator. That equals my right hand side, and therefore that identity is proved. If you're enjoying the lesson so far, please drop me a like. Let's look at now problem number 4. Prove the following. So they gave me sine 70, sine 10, sine 70, plus cos 350, sine 160 equal half. So either the sine of 30 or the cos of 60 would give me a half. Right? Because I have sine there and cos sine with a plus, I assume I'm going to change. Because it must read sine cos, cos sine, or it must read cos cos sine sine. Right? So I'm going to make it sine cos, cos sine. Right, so if I use that, I'm going to use sine A plus B equals sine A cos B plus cos A sine B. So 10 degrees, I'm going to leave as 10. To change sine to cos, I always bring in 90 degrees, my co-ratio. So therefore, sine 90 minus 20. Right, so I'm making that cos 20 degrees. 360 or 350, I have to make 10 now again. So cos would then become 360 minus 10 degrees gives me 350, so they have introduced 10. And for 160, 180 minus 20, 20 degrees introduced, 20 there. Alright? So the key concept is I'm trying to get the same angles while creating sine, cos, cos, sine. So that's sine 10, 90 minus 20, first quadrant. Sine then changes to cos because of 90, so it becomes cos 20. So now I have sine cos. There 360 minus 10 falls in the fourth quadrant where cos is positive. So that becomes cos of 10 degrees. Sine 180 minus 20 in the second quadrant, sine is positive, so that becomes sine 20. So now I have sine cos, you see there's sine cos, cos sine. Same angles. So if I reduce now, I'm going to use sine, angle 1 plus angle 2. So there, 10 degrees plus 20 degrees gives me the sine of 30, and the sine of 30 equal half, to equal my right hand side. Alright, I hope you enjoyed the lesson. Continue working hard. God bless. Bye.